Composition of functions graphically. So I'm given f of 2. 2 is where the x should be. So that means when x is 2, I'm looking for what y is. So on the f graph, I find 2 on the x-axis, and the graph has a point at 2, -5. So y, f of 2 is -5. On the g graph, when x is 2, the graph is at 2, -1. So -1. To do f of g of 0, I'm going to do the same thing. I'm going to do g of 0 first. So when x is 0 on the g graph, y is 1. So instead of g of 0, I'm going to have a 1. F of 1 is -2. Because on the graph where x is 1, y is -2. Then f of g of 4. G of 4, I go over to 4, the graph touches at +4. So f of 4, because g of 4 is 4, f of 4 is -1. F of g of 2. So on my g graph at +2, the graph is at -1. So f of -1. At -1, we're at about -1/2. G of f of 4. So now we're going the opposite direction. I'm doing f of 4 first. So on my f graph at +4, y is -1. So I'm going to do g of -1. On my g graph at -1, y is 2. Now it switched again, g of -2. So I'm going to do g of -2. On the g graph at -2, y is 3. So I need f of 3. F of 3, +3, is at -3. The last one is a little bit of a challenge. We're doing f of g of x equals 3, and I have to find x. So if f of g of x equals 3, then whatever g of x is, y is 3 on the f graph. So on the f graph where y is 3, the x portion is 6. So g of x is 6, because at 6 it equals 3. Then I have to work again on the g graph where y is 3, what is my x? So first I found g of x, now I'm finding x. So when y is 6, x is 5. So x equals 5.